All right. Hello, you guys. You better be being on your very, very, very best behavior today for Miss Sweeney, because she's the bomb. So what I want to do, what you guys should have already done is you should have done 1 through 5, I believe on page, hold on, let me double check that. On page 41 to 42. Okay. And this is what we started talking about yesterday, as far as unit rates with complex fractions. So you guys should have answers. If you get them wrong, you are to write them down as I go through them. But you should have answers for each and every one of them. So I'm going to talk really loud. Hold on, let me see if I can find my microphone so I can plug it in so you might be able to hear me better. So let's see if this will work. Try to move it, but I will be loud. That's not anything hard for me to do, right? And Piper knows this because Piper was one of my students a long time ago. Not long ago, right, Piper? All right, so here we go, here we go. The first problem says this. In this example, so a baker uses 3/4 teaspoons of yeast, 1/3 cup of warm water to make rolls. How many teaspoons of yeast does the baker use in 1 cup of water? So one method that you could do is you could make a table showing the amount of teaspoons of yeast for every cup of water until you get to 1, right? The other way that you could do this is you could set this up. Now remember, the important thing about this is how do you set it up correctly? So as far as what goes on top and what goes on bottom. Well, if we're looking to find how much yeast per 1 cup of water, that means the water is going to go on bottom because it's just like a unit rate. And unit rates, we have 1 as the denominator. So here is my complex fraction. Now, to solve a complex fraction, this fraction bar, remember, not only is a fraction bar, but it's a division sign. So this is really 3/4 divided by 1/3. And then what we're going to do is keep, change, flip. Now, unfortunately, I can't cross simplify anything, so I multiply everything straight through. So this is 9/4. And when it's bigger on the top, it must be improper. So this comes out to be 2 and 1/4. So this is teaspoons per 1 cup of water. Okay, so there is what your answer should have been. Okay, all right, let's look at B. The baker fits 26 rolls on a pan that measures 1 5/8 feet squared. How many square feet does the baker use for each one roll? So we're looking for how many feet squared per 1 roll. So that's how we would set up our fraction with the feet on top and the rolls on bottom. So it's going to be 1 5/8 divided by 26, because 26 is the rolls and 1 5/8 is the feet squared. Okay, feet squared rolls. So now let's write this out as a division problem. 1 5/8 divided by 26. Now, if you don't have a calculator, or if you've forgotten how to use your calculator, then you're going to have to go old school. So you're going to change this to an improper fraction. So that becomes 13/8 divided by 26/1. Keep, change, flip. Okay, now look crossways. Oh yeah, 13 goes into 13 once, 13 goes into 26 twice. 8 and 1 don't simplify, so I multiply everything straight out. 1 times 1 is 1. 8 times 2 is 16. So here it is. It's 1/16 feet squared for every 1 rule. Okay. Notice when I get my answer, I write it back into what I was trying to solve. Okay. So again, you might need it to pause this so you have enough time to write it all down. Moving on. Page 42, number 2. Kenji mixes 1/5 pound of clay soil with 1/8 of a bale of straw to make adobe brick. How much clay soil will he need to make the whole bale of straw? Okay, so let's go through this again. Right now, he mixes 1/5 pound of clay with 1/8 bale of straw. Here's the question. How much clay per bale? Clay per bale of straw. Sorry. All right. So that's what our ratio will look like. So let's plug in what we know. The clay, how much clay does he have? He has 1/5. The straw is 1/8. There is your complex fraction. Now let's get it so that it's a unit rate that has 1 on bottom to represent the 1 bale of straw. So this is division. So 1/5 divided by 1/8. Keep, change, flip. Multiply everything straight through. 8/5. It's bigger on the top, gotta be in rubber. So this actually is 1 3/5. So my answer is that he needs 1 3/5 pounds of clay per 1 bale of straw. So again, you might need to pause that. Heck, you might need to rewind that and watch it again if you didn't understand it. Number 3, the soccer field in a park is 9,000 square yards. The soccer field takes up 6 2/5 square inches, on the map of the park. How many square yards does 1 square inch on the map represent? So how many square yards does 1 square inch take up? So we're looking for yards squared per 1 inch squared. So that's how we set this up. So that means we're going to go back up here and look. Here's my yards. Here's my inches. So yards go on top. 9,000 goes on top. 6 2/5 goes with my inches, goes on bottom. Okay, so again, you have 2 options. Well, this time through, so this actually is 9,000 divided by 6 2/5. Well, this time I'm going to show you using a calculator. All right, so you would just go 9,000 divided by 6 ABC 2 ABC 5. Whoa, and that, look at what it did. It actually changed it into a decimal, which is fine. So this comes out to be 1,406 1/4 yards squared per 1 inch squared. Okay, and that's what that means. So basically, what this means is the soccer field just takes up this amount of the whole thing. All right, last but certainly not least, ooh, my favorite thing. I love Shark Week. Shark Week, Shark Week. It's my favorite. It's my favorite. So here we go. And again, you might have to pause that, rewatch it, or do whatever you need to do to write it down. Number 4, at top cruising speed, a mako shark can swim 4 kilometers in 1/10 of an hour. A blue whale can swim 5 kilometers in 1/4 of an hour? Which animal swims faster at the top cruising speed? And how much faster? So we, in order to be able to compare these, we have to find the unit rate of kilometers per hour. That's what will tell us our speed is. So it's kilometers per hour. So let's start with the shark. Shark attack, shark attack. Shark. So what we know is that the mako shark swims 4 kilometers in 1/10 of an hour. So there's our complex fraction. So to get the unit rate, all we do is divide. So it's 4 divided by 1/10. So keep, change, flip, and here it is. It's 40 kilometers in 1 hour. So there's our shark. Now let's go to the blue whale. The whale goes 5 kilometers in 1/4 of an hour. So keep, or this is what it would be as a division problem. And we're going to do keep, change, flip, and that comes out to be 20. So this is 20 kilometers for every 1 hour. So the shark swims 20 kilometers per hour faster than the whale. And how I got that is because if the shark swims 40 and the whale only swims 20, 40 minus 20 is 20. So the shark swims faster. Okay, so again, you might have to go back and rewatch that. You might have to pause it, whatever you need to do to make sure you understand that. Now, what you guys are going to do is you're going to complete one iReady lesson. All right. And remember, you have to fill out that form correctly. If that form is not filled out correctly, you do not get credit for passing a lesson or doing a lesson. All right. When you're done with those lessons, or when you're done with that one lesson, then you are more than welcome to go and go back to your learning games on there. All right. So that should take you to the end of the period. Make sure you're on your best behavior for Miss Sweeney. Okay. Have a great day.